Greetings, everybody. So what you're looking at here at the top is a problem from my math lab that somebody drew my attention to. And I thought it'd be good to make a video to talk about how to do it. Before I show you how to do this, I want to make a disclaimer. So first thing, I am aware that in our time, I can go to some online calculator. Here's one, for example. And I could type in what's the derivative of such and such, which is what this problem is asking me. And I can hit enter and it will give me the answer. In fact, this one will give me alternate forms of the answer. Okay, so I'm aware that you can do that. Now, that's not, in some ways I don't have a problem with that, but it's also doing this alone is not the agenda in our class. And if you can do that, anybody can do that. Anybody can type a command in, hit enter, and copy an answer down. And so that's not our objective, all right? Okay, so our class is such that I hold you accountable, or I'm supposed to hold you accountable for learning how to use these symbolic rules. Now, whether you see a point to that or not, that is something that sets you apart from everybody else if you can do that, because like I said, anybody can type a command in and write the result down. Doesn't take any special skill to do that, but learning how to follow symbolic rules as we do in math is different. Okay, it requires some skill, and that's what I'd like to show you here. Okay, so that's the disclaimer. I got that out of the way. Here is the objective of our class: to find the derivative of this, knowing the rule and understanding the rule as it applies. Here's the rule that would apply to something like this. It says the derivative of k times x to some power n, where k is any constant. A constant is a number like 3 or 8, right? And n, the exponent, is any constant. It could be a fraction, like a half. It could be a negative number. It could be a whole number. So k, this coefficient, any constant, any number you want. The exponent, also any constant, any number you want. If you have that, the derivative is found this way. Carry the k through, bring that power down, multiply by it, subtract 1 from the power. That's how we read that rule. Okay. Now, when we write this d over dx right there, in math that's called an operator. It tells us what we're going to do. It gives us a command. It says find the derivative of k times x to the n. Okay, and here's how you do it. All right, so that's how I read this. I read this question as saying find the derivative of 3 times x to the negative 1/2 plus 8 over x to the 5/2 power. All right, now, so I got a rule that applies to that. Let me give you a quick example of just this rule. Does this rule apply to this? Does it apply to finding the derivative of 4 times x to the power 5/2? I don't see why not. It says to find the derivative of a number times x to some power, any number. So yes, that rule would apply. I carry the 4 over, just like the rule says. That's like what the k is doing here. I bring down this exponent and multiply by it. That's 5/2, and I subtract 1. 4 times 5/2 is, I guess, 20/2, which is 10. And then 5/2 minus 1 is 3/2. So, okay, yeah, that's it. 10 times x to the 3/2 power. There's your derivative. Now, there are different ways we could write answers, okay? Let's see, I notice in my math lab, it gives these exponents not as fractions like 1/2, but as decimals like 1.5. Could you do that? Could you say 3/2 was 1.5? Yeah, same number. So I guess you could, unless there were some instructions to give the answer in a specific way. Okay, so I've given you the rule. I've explained a little bit about how to read the rule and think about the rule and hopefully recognize when to use it. And then I've showed you an example. Let's look now at how this rule would apply to this problem. Okay, so it says find the derivative of 3 times x to the negative 1/2 plus 8 divide by x to the 5/2. And I think we need to hold off on taking the derivative. Okay, do you see why? Part of learning to use these symbolic rules is learning how to recognize when they apply. This rule doesn't apply to 8 divide by x to the 5/2 power. It applies to some number k times x to some power n. It doesn't say anything about dividing. 8 divided by x to the 5 over 2 just doesn't look like this. So can we turn this into 8 times something? That's what we need to do for this rule to apply. And it's possible to do that. Now we'll have to go back to something that you should have learned in algebra. If you didn't, it's something we can review. But it says, if you have a number to a power, if it's under the bar, you can move it above the bar, but the exponent will switch signs. So like 1 over x to the n, if you want, you could say that's x to the negative n power, and vice versa. So whenever you move something to a power from below the bar to above the, whatever, the exponent will switch signs. That's all I'm trying to say. So we could move that. I could put that, instead of 8 divided by x to the 5 over 2, it allows me to say 8 times x to the negative 5 over 2. So the rule would apply to that form of it. So rewriting is necessary. Okay. All right. So now that I've got this written in a way where my rule applies, I can apply the rule. Okay. So I carry down the 3. I move that negative half down and multiply by it. I subtract 1 from that exponent, just like the rule says. I carry down the plus. Okay, that's technically another rule that you would carry down at addition or subtraction. Okay, carry it down. Carry down the 8. Bring the negative 5 over 2 to the front. Multiply by it. Subtract 1. So putting all this together, I'll get 3 times negative half. That's negative 3 halves. Subtract. I get exponent negative 3 halves. 8 times negative 5 over 2 turns out to be 20. Negative 5 over 2 minus 1 is negative 7 over 2. So I'm done at that point. I applied the rule and I simplified what I could. All right. Now, so that would be okay. You could leave the answer just like this. I do notice, look here, this writes, instead of fractions, decimals. I guess that's okay. It doesn't say you can't do that. So what's 3 over 2? That's 1.5 if you write it as a decimal. Hence the 1.5s. Then there's that 20. What is 7 over 2? It turns out that's 3.5. So I still get that answer. Maybe this looks a little bit different, but I think, again, part of learning how to really do some math is recognizing different forms that numbers can take. All right. All right. So that's how it's done. That's how we can do this problem. And I think I've told you how, all right, obviously with the rule, but maybe explain some things a little bit deeper that could help you also. Okay, so I mean, once you learn it, if there are times when you want to make things easy and use a calculator online or something like that, that's okay. But there will be times in our class, say for the test, where the rubric will state specifically that I'd like you to demonstrate that you know how to use the rule. Because like I said, that's part of our class. Learning to use symbolic instructions is part of learning some math. And at least with the way things are, that's the way that it is going to be.